Yes,
let's
Krish.
yeah. So let's create a data set. Let's create data set and let's write their sales.
Let's see.
Sales and let's write the first data point. Let's give it as the first T1 or something like give a T1 or something or S anything one.
Okay, I'll put 2 there.
Now, second point, if you suppose you have it is an additive, so let's say 2 plus 3. Next will be 2 plus 3. Just write there 2 plus equal to 2 plus 3 equal to 2 plus 3. Don't take top value. We'll just write one by one. 2 plus 3.
All right.
Right next one is 2 plus let's say 3 plus 2 or 3 plus 3. Instead of making 2 plus 3, let's make 2 plus 4. 2 plus 4.
Okay. This one is 2 plus 4. This one is 3 plus 3.
No, the third one is 2 plus 4.
It was 2 plus. Should I make it 2 plus 3 then?
Yeah, 2 plus 3. Then 2 plus 4.
Okay. Yeah. So I have got 2 plus 3, 2 plus 4. Should it be 2 plus 5?
Now after this, let's use some other number. 2 plus 6. We should instead of using a linear, we should something else. 2 plus 10. Right. Let's say this is a small data set, and where we are saying that we are adding data in a, and this will be trend. Okay, this is a trend. 1, 2, 3, 4, 5, 6, and we are saying this is clearly trend. If you plot the graph, let's plot the graph of
Select data in the.
Okay. Now let's put another
So
graph.
yes, there is a trend.
Yeah, this is a trend. This is a very linear Now let's put another graph next to parallel to that. Let's not plot. Let's plot in numbers.
Mm-hmm.
So there's a sales 2. And here, let's say first value is 2 again.
First value is 2 again. Okay.
Second value is it's power of 2. Let's write a formula equal to power. Okay, 2 to the power 2 comma 1. Next power this second one the power comma 2 comma 2, sorry, not 2 comma 2.
1, yeah.
It's 2. You can use that time period one. The time yeah. Okay. And plot this curve inside the same sales one.
Yes. Right, so it is rising exponentially.
Exponential. Right? And this is happening the power of 2. Right?
All right, okay.
Right. So suppose something is multiplicative, multiplicative of the something is rising in a multiplicative form, and something is rising in a additive form. Something is falling in a multiplicative form, and something is falling in a multiplicative additive form. Falling down, right? There two things can happen in the trend. One is it can go either it can go up or it can go down. Right? It will fall down.
Yes. So this would be an additive trend. This becomes a multiplicative trend.
So this is what the difference between the additive trend and multiplicative trend, right? So what we are seeing here is that one thing is moving up at a rate of some power, and something is moving up at the rate of not a power but at a rate of some linear value. So we can see, and let me draw. Suppose if you can open any. Suppose what I say, there is a graph. Right? Let me share my screen now. I'll show you one graph, how the graph looks like.
Hi, this is Wahid.
Hi, Wahid.
Hi, how are you?
I'm fine. Good morning. So we have Ananya with us today.
Okay. Yeah, I missed out. Actually, that's why I thought that it's up here.
Yeah, no problem.
Okay. So, what is the plan to start? What is the plan to start the kickoff session today?
No,
I mean, like in
no. Kickoff session. Our batches we're going to start on 10th February.
10th.
Our kickoff session, our batch kickoff session is on 10th February.
Oh, 10th February. This is just.
Yeah, this is a different batch. This is a different batch. So I think just to keep you engaged as you.
Okay. Perfect, sir. Thank you. I'll be moved.
Just give me a minute. I have to change my nib of the pen. Just give me. Yeah, just give me a minute. Okay, I'm back now. So suppose generally what happens is trend may look like this, right?
Are you sharing your screen?
Okay.
Yes, I can see your screen now.
Okay. I think we know the difference between the seasonality, right? Or what is seasonal? How we have to assess seasonality.
Yes.
So if you suppose if you have a graph, just before that, I just want to just recap that. Seasonality means suppose if you have a data and your peak and troughs have equal gaps, right? This is suppose this is second period we have a peak. This is the fourth period we have a peak. This is sixth period we have a peak, right? This is the first period we have a trough. This is the third period we have a trough. This is fifth period we have a trough, right? The distance between the two peaks is 2 period here. And distance between the two peaks is again 2 periods here. The distance between two troughs means two bottom points is again 2 periods here. The distance between the two troughs means the two bottom points again consecutive one 2 periods here. So if you have such kind of equidistance between the crest and the troughs, the equidistance number which is we have, that we will call it as seasonal, right?
All right.
So now here, if you look at this is not equal. There is a gap. There is a peak here. There is a peak
All
here.
right.
There is a peak, but there is one more small peak is there. A big peak is there, and there is there's one more peak here, right? There is a gap. After gap, there is a peak here. So the distance between the peaks is not equidistant here, not equidistant. So we will say there is no, even though there are cyclic patterns are, these are all cyclic patterns. They are cyclic, but not seasonal. Seasonal will have a pattern, equidistant pattern between two peaks or two troughs. But in this case, what we are seeing the peaks, but the distance between these two peaks are not equidistant from one point to another point. Okay, so
Right.
that's why we call this is having a trend, but no seasonality.
Okay. But we do have these peaks at irregular intervals. Is this defined by cyclicity and not seasonality?
Correct.
All right. Okay.
If it is, if you see the graph, and if we the peaks and troughs are not equidistant, then we say that is cyclical.
Okay. So do we include that in the model, or do we consider this as being the non-systematic component or noise?
The cyclical pattern is a random pattern. So
All right.
yeah, if it is a random pattern, we cannot actually create any model based upon that.
Right.
If it is a random pattern, if it is if it's having a pattern which we can actually replicate for futures, then I think yes, we can actually we can go with that. But cyclic patterns we cannot actually replicate. So like the best thing is that if you want to eliminate the cyclic pattern, you can eliminate it. So that's all different techniques which we learn later. How to eliminate the pattern, how to eliminate something in the model. So now coming back to the point of additive and non-additive, or multiplicative or non-multiplicative, right? So now if you see, this is a graph, and if I have a trend like this, or if I have a trend like this, so this is moving in a pretty linear way. This is additive. But if this is moving in this way, which is moving at a power of some number, this is multiplicative.
Okay, so sir, in the second case also it seems to be a straight line. Maybe for it to be, I could be wrong, but maybe for it to be multiplicative, in the initial stages it would grow slowly, then suddenly it would increase exponentially. That's what we saw in that 248 example.
Yeah, it could be, it's not necessary that initially it will be less. Initially, always the first value is always less, right? First value always be less, right? There's not, that's the starting point will always be, the starting point will always be like this. So what is, how it is moving from this point to another, this point, this point, this point. So again, suppose if I plot this curve.
Actually, sir, in the second example, it seems that the rate of increase is constant. I'm trying to imagine, and I could be off the mark.
Yeah, if you can, what is important is how the rate of change is happening, right? Okay, so you are saying constant here, right? Because let's say this is happening, this is 2 plus 2, this is happening 2 plus 2, 2 plus 3, and 2 plus 4. But this is moving 2 plus 1, 2 to the power 1, 2 to the power, maybe 2 to the power 3, 2 to the power 4, 2 to the power 6. Or if we suppose we have what we have seen in the graph, right? This is moving like this.
Right, yeah.
2 to the power 1, 2 to the power 2. This is also multiplicative. This could also be multiplicative.
So the third one more visibly evident that it's multiplicative.
Yeah, multiplicative.
All right, sir. Like from figure, I could understand. Is there a way to prove mathematically from to the equations that this is multiplicative or this is an additive trend? Suppose you have the numbers, then can we derive a formula to establish the nature of the trend?
See, nature of trend, if it is, see what happens if it is multiplicative, right? Then we will have a lot of error. if suppose if you use a linear regression,
Mhm.
if you use a linear regression model to actually to predict the numbers, if it is a multiplicative model, multiplicative trend, then we will have an issues, right? This will not be a, suppose generally what happens is in the linear regression, whatever data we have, right, it is going to give us some kind of, suppose this is our intercept,
Mhm.
C,
Okay.
C plus mx, right?
Yes.
This is C, this is mx.
All right.
So the line is, the forecast model is C plus mx. Suppose this is a straight line, and if we want to plot this one, suppose this comes over here like this, right? So, or let's say this comes, this may come like this also, or this may come like this also. So what will have been a lot of gaps will be there between the either it will be close to the end the end of the data, or it will be close to the starting point. But even if it is close to the middle points, the gap between starting point and ending points will be there. Now, what is the meaning of this? Suppose if my data is spread like this, if data is spread like this, right? What it is saying, it is taking the line through the middle of this distribution. If it is taking the line through the middle of distribution, the gap between the initial distribution and the ending distribution will be very high. If my line is going like this, for example, instead of this stopping over here, we'll stop it here. Now, what second line is doing? The second line is trying to go close to the ending distribution. Or we can go with like this also. Third one.
Okay.
So the what is called the least square error, right? So the least square error means the gap between the distribution and the prediction line. So the whatever is the gap, then it is going to do the square error of that, and that is called least square error. So the line is going to be derived, or line is going to be derived based upon the least sum of the least squares, square between the historical distribution and the predicted line. So just somebody is joining there.
I think Vahid, I'll just add to him. Drop
Okay.
and rejoin.
Okay. So what is happening here is that there will be a problem because if we plot this kind of data with the linear graph, linear regression, then there will be plenty of problems. So what I suggest is go with a multiple regression.
All right. Okay.
Go with multiple regression and identify, because if multiplication is happening, then I'm damn sure it is not because of seasonality. It's not because of some time period. It's just not because of the time. The cause is not just any time, because time is just not going to, if you see in history or anywhere, time is not going to drive the sale for long period of time, or multiplicative. Suppose if you want to talk about multiplicative sales.
Right. So, sir, actually, I was talking from from the point of view of double exponential smoothing. So there is this Holt exponential smoothing, which has got two formulas: one for the trend and one for multiplicative trend and one for additive trend. So I was looking at a data point which had no seasonality; it had only trend. So they said that double exponential smoothing would work for that. Now there were two different formulae for one for additive trend, one for multiplicative trend. One was it was adding the trend component to the level. In the other case, it was multiplying the trend component to the level, and also the step number k was raised to the power of the trend.
Okay.
So even the formula is varying depending on whether this trend is additive or multiplicative. So if I have got a set of numbers, then I was thinking we should be able to identify that whether this trend is multiplicative or additive. Based on that, we can adjust the algorithm that we apply.
Mm-hmm. Yes, if you plot, see, the best way is to understand is whether we have multiplicative trend or additive trend. The best way to identify is that plot, right?
Understood. Okay.
Statistically also we can do, right? There is no, but statistically we cannot do. We can also do, right? What is the increase? Suppose if something happens, something increases at a very short period of time, and something increases
Okay.
over a long period of time.
Mhm.
Right? Something is increasing short period of time, and something is long period of time. So that is also one way to look at it. Suppose the algorithm, if you say that the algorithm is for example, if you convert a number, suppose we have a 2, 4, 8, right? And we have 2 to the 4, 16 to 16, and 32. And 32, right? This is our numbers. This is a power of 2 to the power 1. This is 2 to the power 2, and 2 to the power 3, 2 to the power 4, and 2 to the power 5. This is actually the distribution. Now, if I convert this number into log, I do the transformation now.
Okay.
I do the log transformation of these powers. Okay, so log of 2 to the power 1, log of 2 to the power 2. Now, if we plot this data, right? Now we plot this data. Maybe we'll see these numbers which are having a multiplicative trend may get transformed into a linear trend.
Correct. Yeah.
So this could be one of the way we can handle the multiplicative trend. And then once the linear trend is forecasted, then we go back to the anti-log. Anti-log to get the numbers which are which could be comparable to the original data points. So a multiplicative trend, whether there is a multiplicative trend or not, right? That we can actually look at by the log transformation also. That we can actually look at from the log transformation point of view also, and we can see the correlation value. The correlation value with the normal numbers, and the correlation value with the log numbers. Can we do in a case that data which you have on your screen? Can we do on that?
Okay. So the data that we just created.
Yeah.
All right. Can I share my screen?
Yeah. Please share your screen.
Back to the screen share. So log transformation of this one, right?
Yeah, log transformation.
Right. So now what we have is a linear increase. So if we take a log, then if it's a linear increase, then it would indicate that there is multiplicative trend here. Then do we build our series with the log cells too, and finally we take an anti-log?
Yeah, we can do that. But before that, I want to check, find the correlation. Find the correlation between the non-log and the log. The correl is a formula correl.
Okay.
Use a formula
Yes, I have used that. Yeah. So I'll take this thing, and with this thing, there should be a very high degree of correlation.
We have to do the correlation between the time period and sales, then time period with log sales. The two different formulas. We want to compare the correlation values.
Okay, got it. First, I'll have time period and sales. It is 0.9, it has increased. এটা হলো তারপরে ব্যাপারটাকে বোঝা যাক। Okay, so it's perfect correlation. Okay, maybe did I make this is A2 to A6, A2 to C6, that's great. Yeah, there's nothing wrong in the formula, but here I'm seeing a perfect correlation.
Yeah, straight line, right? It's at 45 degree.
Yes.
So if you have a slope at a degree of at an angle of 45 degree, the correlation will be 100%.
One. Yeah.
Do we have any sample with you where you are working on this project? Do you have any sample?
Okay, sir, actually, I only rate this in a theoretical format. So I'll just take my phone out. I'll tell you, the YouTube channel had find that.
Okay. Okay, before that, let's do one thing. Let's do the forecasting for log sales. We'll apply that multiplicative model for sales and additive double exponential for log sales.
Yeah.
Right? We'll apply the multiplicative double exponential for the sales and additive double exponential for the log sales.
Okay, sir, I forwarded you that video where I had seen this.
Yeah.
There, this person explains the formula there and kind of an overview. So I did not have any hands-on project where I could get these doubts clarified.
What would you do if your boss?
Okay. So we'll do that later. So let's do over here first.
Okay. So can you repeat once?
Yeah, we will do the multiplicative double exponential on sales to data and additive double exponential on log sales data.
All right, got that. So this is sales 2. This is controlling. Okay, so on this one we will be doing multiplicative exponential. Okay. So I have this right. So f of t plus 1. Okay, but this is not single exponential smoothing. This would be double exponential smoothing. Okay. So f of t plus 1, that would be, what was the formula for that?
Double exponential is you have to first find the trend forecast. So trend forecast plus the what you say that what you say LT plus LT is your level. Sorry, yeah, level. So level plus trend, right? Level plus trend plus noise, randomness. So what you do here is first we need to first forecast our the level, then we'll forecast our trend, and then after that we'll add the level and trend.
All right. So
okay. So first let's go back to the Excel sheet, and we'll do the level forecast in the way we used to. We can do. Okay, let's go back here and just. So let's do level forecast there.
Okay, so this level ka formula, I think it was alpha into yp minus 1.
Yes.
Plus 1 minus alpha. with that we were having the
FT minus.
previous level plus previous trend.
Yes.
That was one. And trend for this time, it was beta. No. Yeah, this was beta into the difference of the levels.
LT minus 1 to LT to LT minus 1.
Yes, LT minus of LT minus 1.
Yeah.
And I was doing 1 minus beta.
Into,
उसके साथ I was modifying the previous trend.
yeah.
So okay, so I'll have something like a alpha over here. Beta plus 1 minus beta. Let's begin at 0.3. This number. Okay, now if I'm trying to build the multiplicative trend, then the forecast would be level multiplied by trend. Okay, so to the power k depending on the step. Okay. Alright, so first is that I try to find out the level ka value, then I will try to find out the trend ka value. उसके बाद first. So first level is that I just copy the cells. Okay, this trend over here, this would be difference between these two guys. Yes, sir. Is this the right trend? Like the very first trend, I'm doing 4 minus 2.
No.
Yeah, actually, it should be the other one. This is the value of the trend. So
No.
So how do we have
No.
the first trend?
First, what we have to do is just the first value. The first value is our 2, right? 2. We are taking level 2. Why 2? Not like we have to take. You have to take average or take the intercept.
All right. Known wise, known X. That's the first level. How do we get the first trend?
Yeah, first time we can do 4 minus 2.
Okay, but
Is it minus 9.2?
this one, yeah, it's minus 9.2.
Okay.
That's because when it is back plotting this number, it is going further below 2.
Really, I think we should not get 9 because we should have positive intercept because we have a we should have positive intercept. See, here it is. You can see. Check what is B1 to B1 to B1 to B12 to B16 and A12 to A16. Is it we don't have negative value? Okay, let's not go to negative value. Let's go to.
So can we simply take average?
Take the average.
Okay. Problems test. What is it now? We take another. So average is sorted. So
Yeah.
trend T. So I think this formula is correct. Wherein at third minus T minus 1, that difference of the two cells is my trend.
Yes. Now what we'll do is we can create a trend forecast. A trend could be like we can do 4 minus 12 or we can do 4 minus 2. Right? We can do 4 minus 12.4 or we can do 4 minus 2. Either of this we can do. The first one. So let's do 4 minus 2. So now we have No, first one, the first period.
Okay, sir. What was the first option?
The first option is we can do two things. We can do 4 minus 12.4.
Yes. So how do you suggest like we get?
So this is our level is 12.4, right? So level is 12.4, and here
4 minus 12.4.
yeah, that is one way. Or we can also go with 4 minus 2 also. B13 minus B13 minus B12. We'll see both the methods. B13 minus B12. Okay.
B13 minus B12. Yeah. So that's how I'm getting the second trend.
No,
Third trend,
second
and so
trend
on.
we have to forecast. From second trend on, we have to do the forecasting. We cannot use this formula 4 minus 2, 8 minus 4. We can't do. From second onwards, we have to do subtraction of our. We have to use the formula that which you have written beta into LT minus 1 into LT plus LT, LT minus 1 minus LT plus.
Voice is slightly breaking.
Okay. Hello, is it okay now? Hello. 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 Hello, Ananya.
Can you hear me?
I can hear you clearly. I can hear you very, very clearly. Hello.
Hello.
Yes, Ananya, I can hear you very clearly.
Yes. Now I can suddenly hear you. Maybe there was a network issue
Okay. Okay.
at my end.
Yeah. See, there are three ways which you can. Are you able to hear me? Hello. Hello, Ananya.
Right now I am able to hear you well.
Okay.
Hello,
Okay.
sir, yes, can you hear me?
I can hear you clearly. Are you able to hear me? Wahid, are you there? Are you able to hear me, Wahid? Wahid is not there. Hello, Ananya.
Sir, I'll just drop off and
Yeah. Yeah. Okay.
reach. Hello.
Yeah. Yeah.
Yeah. Yes, sir. Abhishek, it became better. Yes. So I was just thinking, how do we get the first trend?
The first trend value. There are three ways to three ways to execute. Right. First way is you can do B3 minus B2. Okay. Or you can do B3 minus C. Sorry, B3 not B3 minus B2. B13 minus B12. B13 minus B12 is first way. B13 minus C12 second way. Or C12 minus B12. Hello. 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 Hello.
Hello. Yes, sir. I just rejoined.
Okay. Are you able to hear me now?
Yes, sir. Actually, I can understand the problem. So there's a small mouse around in the house. So every time I close the door to keep it away, the internet connection quality drops.
Okay. Okay. Okay.
Yeah, I have now opened the door, so now the connection is good.
Okay. Okay. So is it okay right now? Is it okay now?
Yes, it's okay right now.
Okay, so there are three ways we can actually get our first number, first trend value.
Right, sir. Okay.
Yeah.
So one way we check.
One way is
that
we can do B13 minus B12. B13.
B13 minus B2. Okay.
Second way is we can do B13 minus C12.
B13 minus C12. Okay.
And third way is we can also do by this B12 minus C12.
B12 minus C12. Okay. Sir, I had a question with one approach wherein you said that we can do that by B13. Yeah, B13 minus B12. So the trend at time t, this is trend at time. So trend at time t, this would be sales at time t minus sales at t minus 1. So what you said is applicable for the second trend. Why are we calculating the first trend also using that formula?
See, what we are trying to do is that we are trying to use a assumption there. We are not saying that there is a trend going to start from first value, right? We are trying to like we are assuming the first level 12.4. We're assuming 12.4 by taking the average. So similarly,
Okay, so this is an assumption.
assumption,
Okay.
right? This is an assumption that we have our trend will proceed in this manner.
Understood, sir. Okay. So I can take that value.
Yeah. Now from second values, we are going to do the forecasting of level as well as trend using our smoothing constants alpha and beta. So for level, let's do the forecasting. We need to have alpha. So go back to the so that is C13. Yeah, I think is your screen moving? Are you able to share the screen, or this previous screen I'm able to see that?
Okay, I am sharing my screen. Are you not able to see?
No, I am seeing the previous screen. I think just.
Okay, let me stop and reshare. So, are you able to see my screen now?
I can see the screen, but I think I'm not able to see a cursor moving.
Okay. I'm moving the cursor. Can you see now?
No.
Okay.
Can you do one thing? Can you rejoin? Just log off and log in once again.
That's yeah. I'll do that. Okay. Hello, sir. Let me know if you're able to see my screen this time.
Just a minute. Again, I'm seeing the old screen. Just refresh the page here. Now you can share your screen.
Sir, I'm already sharing.
Okay, I'm still seeing a dark screen here.
Okay.
Not able to see the image of the screen. I'm seeing a dark page.
And I'm, bit confused. What should I do?
Probably the
Let me know.
the internet is slow there. I think that may
Yes,
be.
sir. So I'm working from a different room. Most likely, internet quality is not good here. Maybe, sir, we can, reconnect tomorrow, and maybe we can spend some time on this.
Yeah, no problem. So now you have the idea, right? So just use alpha and get the level forecast, and use beta to get the trend forecast, right? And then you can apply the additive forecasting, or sorry, in this case you have to apply the multiplicative forecasting. And then
Right,
for the log sales, you apply the additive forecasting. and then do the calculation of mean absolute percentage error.
Understood, sir. I'll take that as a homework and I'll work on that. So, sir, on this related point, I had a question. So, when I'm calculating the level, that is LT,
Yeah.
so I had come across two formulas or formulae. One is alpha into YT minus 1 plus 1 minus alpha into previous level, previous trend.
Yeah.
The other one was exactly the same, but instead of doing alpha into YT minus 1 initially, it was considering the current sales value. Are both these correct? Because in cross-turn, in simple exponential smoothing, you taught those variations.
Yeah, the cross. See, what happens is we can do both the things, but as an innovation, but as a bookish part, I think from the bookish angle of for single exponential, for single exponential, it is alpha into YT. Suppose if you're doing FT plus 1, in that case, for single exponential, it is alpha into YT plus 1 plus 1 minus alpha into FT.
All right, okay.
This is for single exponential from the bookish point of view. Okay? From the bookish point of view. If you want to innovate, right? So nobody says that you have to only follow the book. What you have to achieve is accuracy. Right? If you're able to achieve the accuracy by twisting the formula, instead of going FT plus 1 is FT plus 1, now alpha into YT plus 1 minus alpha into FT. Now what you have done, instead of taking the current sales, you are taking the previous sales.
Okay.
Third one we have also seen, we have taken the average of two values, right? YT and YT plus 1.
Okay.
Yeah.
So
So you
for
can
the
apply
double exponential smoothing also, we can either consider the current cells or the previous cells.
You can do that. But the bookish one is current sales, previous sales.
All right,
Right?
sir.
But if you want to innovate, you can innovate it.
Quite. So, sir, I had a couple of other questions. I'll just skip those quickly. So, one is for the single exponential smoothing, I have tried use that solver. So, it recommends a value of alpha, which is like say 0.9. Why doesn't it completely go up to 1 so that the forecast and the sales actually match?
It happens like it recommends even 1 also. If it is recommending
Yes, so my objective, in the solver, I was setting the objective as minimize the RMSE.
So you have to give a constraint. You have to give a constraint there. Constraint means your alpha has to be somewhere around not more than 0.7 or not more than 0.6.
Okay.
Right? Because
so that's a constraint.
You have to add, because we cannot actually opt for overfitting. Right? If it is overfitting, then we can put the number manually itself. If you increase alpha, it will go. The accuracy will go up and error will come down. Right? So if you increase,
understood, sir.
So just give a constraint for alpha.
Okay, sir. With cross turn, you used simple exponential smoothing. So why did it like we can blend cross turn with any of the other methods as well? Double exponential, triple exponential.
Yeah, we can do that. We can do that. Suppose even with TSB also we can do that.
Got it.
Right.
And sir, last question from my side for the day.
Yeah.
So for the last approach of cross turn, or rather the third approach, so we were taking the average of the two sales values,
correct.
Y2 and Y1, or correct. Y3 or Y3 and Y2, like this.
Correct.
And then you were dividing that by serial number 2 minus serial number of 1.
Correct.
So that number would always be 1. So why were you dividing by serial number 2 minus serial number 1?
Okay, but suppose if we have a time horizon, in a different way, instead of taking, suppose if you have a time horizon, if your time series is not between the first month or second month, or not between the first week or second week, if it is from first month to third month, or first week to third week to fifth week to seventh week, means we're trying to capture we are
right. Got it. So the gap need not always be 1. It was an ideal scenario that we checked.
Correct.
All right, sir. Fine. So I'll take this. So cross-turn, there were a few homeworks that you had given. So I'm yet to complete those. Although I watched the video, the next part is the data set that we created. I will apply both additive and multiplicative feasibility and calculate the RMSE on these two.
Correct. Even you can try, but even you can try the multiple regression also.
All right. Okay.
Right. What do you do multiplication? You have to do you have to convert your time series, the time, the time period. You have to convert the time period into categorical data.
Okay.
Suppose you have time period is there, right? Time period is 1 to 7 we have taken. So I think 6 or 7 time we have taken.
5.
5
1
we have
to
taken.
5. Yeah.
So we have first, suppose if you convert into a categorical data, it means it will be a binary data. So suppose your first time period will be first time period 1, it will 1 and rest all will be 0. 2, 3, 4, 5 is 0. Right? Suppose you go to second time period. Second time period, 2 will be 1, 1 to other will be 0.
All right.
Right? So you are going to create suppose you have 5 time period, there will be 4 variables.
Okay.
Right? So you can create 4, if there are 5 time periods, then we have 4 variables of time. And then those 4 time will be your causal variables.
Okay.
Right? So you can do that also to understand the relationship between the time and the sales. So which time period has the maximum impact? Is it T1 or T2 or T3 or T4 or T5?
Understood, sir. Okay.
So that is also one of the way. We'll see that we have actually that is also in plan to accomplish. So just actually we are working on that model which has thousands of SKUs. That's why we were actually limited. Like we cannot opt all this model at one time. That's why we have not covered that. But additive and multiplicative both were in the plan earlier.
All right, sir. Okay.
Okay, so let me know what is the result. Tomorrow we'll meet 9:30. So there's some additional results will be coming from Mongolia. So they will not disturb us. We'll be going ahead with our own program.
Fine, sir. And would it be just me and Sapna would be actively participating?
Yeah, for this batch it is you and Sapna, and there will some people will coming and going on, right? So that is that.
Okay.
But as of now, with you, one more person has to be joined. He has paid the money, but he is not joining.
Okay.
So that's one person is having some issues with his laptop. That's why he's not able to join. Okay, so we'll meet tomorrow.
Yes, sir. Fine.
Okay.
Thank you, sir, for clarifying all the doubts and staying on. Thank you.
My pleasure. Take care. Bye.
Thank you, sir. Bye. Safe journey.